Hi, here we go. We're going to talk about closures now. So what in the world is closure? Closure is a functional block of code. However, a closure can be passed to and from a function or a method. It can capture values from the context where it is defined, even if it's executed outside of that context. So it can capture values. Swift closures, in other words, are similar to blocks in Objective-C or lambdas from other functions. If you have looked at Java 8, you know that you have lambda functions, and they look a lot like closures in Swift. Functions in Swift are actually a type of closure, and we'll look at that here in a moment. Closure syntax, though, should look somewhat familiar because it's really the same as the syntax for a function. So there are three basic types of closure. Functions defined at a global level are really just named closures that capture no values. Functions defined inner to other functions, inside other functions, are named closures that actually do capture values from the local scope, which is the function in which they're defined. Unnamed functions, these are the ones we're interested in. Unnamed functions that capture values from their context are called closure expressions. Now, what in the world am I talking about here? Well, the syntax for a closure expression is this. Notice the curly braces. This is the literal syntax for a closure expression. We have a parameter list, the arrow, a return type, and then the keyword in, and then whatever statements we're going to have for the closure. The keyword in tells the compiler that we're done with the parameter list and the return type, and now we're moving on to the statements in the closure. So for example, we might express a function to find the maximum of two integers as a closure. Notice the curly braces. This again is the literal form of the closure. This is what the closure actually looks like, and here the closure is being defined. A is an int, B is an int, returning an int. In, the keyword in, and now we define what is done with these two ints and what to return. If A is greater than B, return A. Otherwise, return B. So this is a literal closure. In a function that accepts a closure, this is the form that you need to pass to the function. However, when you are writing a function that accepts a closure, you are using that closure's type. And the type of a closure is a closure expression without its wrapping curly braces. So make that distinction in your mind. It is very important. So let's use a closure in a function definition. Why not? Why can't we define our own function that takes a closure as a parameter? And we can. So suppose we define a function that returns int, the integer, having the least value in an array of integers. This might be useful for us. The type of the closure is a closure expression without the curly braces. I'm kind of belaboring the point, but it's important. When you start using these things in a function definition, you're going to want to type the curly braces. Don't do it. You'll get all kinds of errors that you won't know really what they're talking about. So notice, this is called smallest int. It takes an array of integers as its first parameter, and it takes a closure, and that closure's type is take two ints and return a bool. And then the whole thing returns an integer. Smallest int returns an integer. So we got a couple arrows here, and I've made the closure definition, or declaration, not definition, the closure declaration in red, so to kind of call it out for your eyes. Notice also that we provided a parameter name for this closure, least. Okay, so now remember what we're doing here. We are defining the function, not calling the function. So we set up a return value. Retval is equal to an integer 0. Why is it an integer? Because it's inferred to be of type integer. And now we're going to count through the array. We're going to compare each element of the array to the next element of the array, so we only want to count the first n minus 1 elements of the array, because we're always going to be looking to the next one. So looking at this, for var I equals 0, I is less than int count minus 1, I plus plus. Now we call least. Is least defined? Not yet, but we are deferring the definition for when we call smallest int. We're assuming that it's going to take two integers and give us back a bool. So if least int array I plus 1, we return int array I. Otherwise, we return int array I plus 1. In other words, the implementation of least is left up to the caller. And this is the power of a closure. Finally, we return the return value. Now, let's call the function. We have let myints equals 2, negative 3, 9, 81, and 4. Let least equal the smallest int of myints. And now we have to supply the definition of the closure. So what is the closure? A int, B int. A is an integer, B is an integer, returning a Boolean in, here's that keyword in again. Notice that we're using the curly braces. This is because this is a literal closure that we're supplying. And when we say, if A is less than B, return true, else return false. We provide the definition of the closure in the function call. Because we're supplying it as a literal closure, it needs to be in curly braces. Now, is there a shorter way? Sure, there's a lot of shorter ways, but this is the first. Since the types of the parameters and the return type for the closure is already known, it's known because the function that we defined that accepts the closure said we want two ints and to return a bool, we can omit the types. So here we say let least equals smallest int, myints, AB, in. Now, we've also omitted the type of the return type because it knows what it is. It's a Boolean. So we do the same thing. AB, no arrow, no return type, in, if A less than B, return true, else return false. We can also do something a little bit shorter. Because we know that A less than B is a Boolean, we don't have to say if A less than B, return true, else return false. The expression A less than B means if A less than B, return true, else return false. So we can shorten it even more. Let least equals smallest ints, myints, AB, in A less than B. So look at that, make sure you understand that before we go on. Can we get more terse? Yep, we can. We also know in the closure, we also know the number and the position of the parameters in the closure. So we can use something called positional parameters to give us back those numbers. The first parameter in a closure's parameters list, and a function, because functions are closures, the first number in the parameter list, or the first value, is buck0, the second is buck1, and so forth. So we can say let least equals smallest int of myints, the array, 0 less than 1. Parameter 0 less than 1. That will return a bool. It's still a closure. We are in curly braces. This says the same thing. So you can get away with this if you have a set number of parameters, no variadics, if you have no variadic parameters, you can get away with this because you know the position and the types of all of your parameter list. So now you're saying probably, gee, it's still too much typing. And I'm joking probably. But what if you are saying, gee, that's still too long? Well, okay. If you know there's an operator that compares two's types in the way that you want to compare them, we know that the less than operator does this. It compares two ints. You can simply use the operator. This is called an operator function. And this is about as short as we can get. So if it's still too long, I'm sorry. This is about it. But look at this. Let least equals smallest int. Take the array and use the operator function less than. That is pretty cool. I think you'll agree. So, considering the power of this, what if we rename smallest int to min-max and said let biggest equal min-max with that array and the operator function greater than. Would that work? That would work, because the definition of the closure is supplied in the function's call, not in the definition of the function being called. And this is the beauty and the awesome power of closures. When we define a function that accepts a closure, we are not defining the behavior of the closure. We only define the behavior of the closure when we send the closure to the function. And that is great, because now we can send anything we want to that function and make it behave in a multitude of ways. Thank you very much.